Okay, so we'll make a quick program with the robot builder so you can kind of see how it works. This is a long time coming, this demo, but here we go. The robot we're building has a elevator with a potentiometer, it's got a wrist with a potentiometer, it's got a gripper with no feedback, and it's got a drive base with 2 Jaguars. So the first thing we do is we pick the subsystems that are on the robot and create those. So we just drag stuff from this palette into the robot as it's being constructed. So here's a subsystem, we drag it in, we call it drive base or whatever. We make another subsystem, drag it in, we can call it gripper. Okay, this is the claw with no feedback. We can drag another, this time we can do some PID subsystems because we've got some things with feedback. So we can drag in a elevator. So there's an elevator. We can also just right click on here to create things. So we can add a PID subsystem and call it wrist. Okay, and that one also has feedback. All right, so now we've defined the 4 subsystems on our robot, and now what we can do is just start adding devices to them, also using the palette. So the drive base is a 2-motor drive thing, so I can just drag in a robot 2-motor drive into the drive base. And there it is, and you can see there's some options here of properties for the left motor and the right motor, but there's nothing there yet. So we can drag in a couple of Jaguars, so we can drag that into the robot drive. The Jaguars on the drive base are connected to ports 1 and 2. So the right motor is port 1, so we can call this right motor, and it's port 1. And then we can drag in the other one, it's another Jaguar, and we can call it left motor, and that's on port 2. You notice it's auto numbering, it's just incrementing numbers here, so that we can, so you don't have to keep doing this over and over again. So the left motor is the left motor. Okay, there we go. And the red indicates that there's some stuff that's incomplete in this particular subsystem. So now it's complete. We've selected the left motor and the right motor. The next thing is the gripper. Okay, so the gripper is a Victor on port 7. So we can just grab a Victor, drag it into the gripper, set its port to be 7. Okay, and that's it for the gripper. The elevator and the wrist are a little bit more complicated because they're PID subsystems, so those have Victors. So we can drag in a Victor for the elevator, and the elevator Victor is on port 6. So we can click that. And then, but then it also has a potentiometer, because it's a PID subsystem. So we can just drag a potentiometer into the elevator. Okay, and the potentiometer for the elevator is on port analog channel 4. So we could just select 4. And notice that now it says it's complete, and what it's done is it's automatically selected the potentiometer and the Victor for the input and the output, because those are the only 2 choices that were applicable. If you had more things there, then there'd be a combo box, and you can choose which one you want. Same deal with the wrist. We can drag in a Victor. Okay, so there's the Victor, and the wrist Victor is port 5. So there we go. And it also has a potentiometer. So we can drag in a potentiometer into the wrist, and the wrist potentiometer is on port 2. Okay, there we go. So now we've got this complete robot defined with all of its motors and all of its sensors. Now granted, it's not a lot, but you get the idea. Now what we can do is get a wiring table for this. So this is something where you've done the design, you got ports allocated, and then you could give this to the people who are like wiring the robot. So we go to the wiring file, we click to select, we'll put it in this directory called delete me, and we'll just call it GearsBot, and save it. Okay, now we can just generate the wiring file by clicking on the wiring table toolbar icon, and let's see, it's here somewhere on my computer. I just have to go find it. Okay, and here's the wiring file that got generated automatically. Now we can go back to the Robot Builder and generate some code for this. So we click to select a location for the Java project, and again we'll stick it in this delete me directory. And now what we can do is just generate some Java. So we do that by selecting Java. Oh, we want to set the team number, and then we can say just generate Java. Okay, so a project got generated. So now that we have that, we can go to NetBeans, which is here somewhere. here's NetBeans, and just open the project. So we go to Brad, delete me. Okay, and here's the Java project. So here's the source code for the files that it generated. And you can see it's got all of the subsystems. Now the really cool thing about this is, at this point we should be able to just download this program into the robot. So we'll see if this actually works. I think the network connection is set up right. Okay, there it goes. So it's sent the file, it's rebooting the CRIO, and when it comes up, the program should be running. Now, by itself, that wouldn't be very useful because we haven't really written any code yet. But the generated code from the Robot Builder will operate the live window, which is actually the really cool part here. So as soon as it finishes starting up, then I'm just going to pop up the live window. In fact, let's see, almost done, almost done. Okay. So now that the program is running, I should be able to start up the Smart Dashboard. Okay, so here's the Smart Dashboard running, and then put it into live window mode. Okay, and here are our subsystems. So we have the drive base with its right motor and left motor, the wrist with its Victor and potentiometer, and the Victor for the gripper, and the elevator with its potentiometer and Victor. And so what I ought to be able to do now is just operate this. So if I make sure the robot is enabled, okay, the robot is now enabled. If I move the elevator, you can hear the elevator moving, and you can see the potentiometer changing. So you can actually test this thing and see all the values and all the stuff changing. So that's without writing a line of code. And now we have this working test system for the robot, and now we can just start adding code to it to make it that much more useful. But before we do that, let's add some commands. What commands do is they let you do the operations which happen over time for a robot. So we'll add some commands. So one of the commands we'll add will be like, we'll just do the claw because that's pretty easy. So we can do add command, and we can call it close claw. So this will close the claw, and it's going to require the claw or the gripper, because it's the gripper. It will require the claw subsystem. And we'll make another command, say add command, and we'll call it open claw. So you have a couple of commands here. These both require the gripper. All right, now we can implement this stuff to see it work. So we can go to the, we can generate code again. So just hit Java, and it generates Java code again. And it doesn't actually overwrite the project. It just adds stuff to it. And so now you can see we've got these open claw and close claw commands. So first let's go to the gripper, which is the claw, and click on it. And we can add a few methods to it to make it operate. So it needs a public void open method. Okay, and you open the claw. We've decided by setting it a -1. So we can do, what do we call it? Let's see. It's called Victor. So we can say Victor dot set, okay, and it's -1 for the speed. We could have actually seen that using the live window. We could have figured out what which way it had to go. Close. Okay, so this is with a +1. Okay, and then we'll make another one that makes it stop. Okay, Victor dot set 0. So that stops the motor. All right, so now we've got 3 methods in the gripper subsystem: open, close, and stop. Now we can implement these commands. So what does close claw need to do? Well, when it initializes the command, that means when it's first being scheduled, then we have to do robot.gripper. And then this is, let's see, we're doing close claw, so we want to do close. So that will start the thing closing. And we want to do this, we also want to do this for some period of time. So in the constructor, we want to set a timeout for about 9/10 of a second, because that's what it takes to close it. So this is like with no no feedback, just doing this by time. And then when it's executing, it's not going to do anything because the gripper is now closing. But what we want to do is to tell if it's finished or not, we want to just say is timed out. And that will tell us if our 9/10 of a second timeout has happened. And then when the thing ends, when the command ends, then we just want to stop it. So we can say robot.gripper stop. And that will stop it from moving. And then there's an interrupted method in case the command gets interrupted by another command. And we can say, we can just tell it to do the end method, okay, which will stop it. So that's it for this command. And then we can do the open claw method, okay, which is like the same deal. So over here in the constructor, we want to set timeout to be 9/10 of a second again. Whoops. And then when we initialize it, all we need to do is start it. Let's see, we're doing open, so we can do robot.gripper.open. Okay, that gets it open. It gets it going, opening. And then again, when it's finished, if we've timed out, and then the end method, same thing as before. We can stop it. So we can do robot.gripper.stop. Okay, and the interrupted method just calls the end method, so it just stops it. All right, so that's it. Oh, and then the other thing we want to do is just connect these things to a couple of buttons on our gamepad. This is actually way cool. So we can go back to so we've got this code now. We can go back to the Robot Builder. We can add some operator interface stuff. So we can just go and take a joystick and drag it into the operator interface, and then take a button and drag it under the joystick, and call this button close claw. That'll be the name of the button, and it'll be button number 1, and the command it will run will be close claw, and it does it when the button is pressed. So it automatically does that wiring for us. Then we can just take another button and drag it under the joystick, and we'll call this open claw, because we already have close. And this will be joystick button 2, and this will run open claw, the open claw command, when the button is pressed. Okay, and that's that. Okay, so we're pretty good now. Then we can just save the Java project again. Operate the program, so I can press button 1 and button 2. Oh, nothing's happening. Let's see what's wrong. Oh, we're still in live window mode. So we go to the Smart Dashboard, turn off live window mode, and then now, let's see. There we go. Press one button and the claw opens, press the other button and the claw closes. There we go, opening and closing. And that's it. So that's how the live window works, or how the live window works, and how the Robot Builder works.